Hi, this video is an introduction to marginal cost and marginal revenue. So we've already seen before cost functions and revenue functions, and usually the simplest models give us a cost function, a revenue function that are linear functions. And in that case, the average rate of change is always constant, it's always the same, but it's not always the case that the marginal cost is always the same or the marginal revenue is the same. Oftentimes these change with the quantity you're producing or quantity you're selling. They're so-called economies of scale, and that's what economists would call it. So in general, they won't always be linear. So what do we do if they aren't linear? Well, we use linear functions to approximate them. That is, we use the derivative. So let's see an example. Here's a revenue function. It'll be given by a table. Let's give it by a table. I'm going to have the Q is going to be the quantity I produce, and then I'll have the revenue after selling Q units. Makes sense that if I don't sell anything, I don't make anything, so it makes sense to have Q0, R of Q is 0. And then maybe I sell 10 things. Maybe I make 200, the price becomes $200. I sell 20, maybe the price is now, I make $400. So the price here looks like the price was $20 because 20 times 10 is 200 and 20 times 20 is 400. But you know, something could happen here. For example, if I make a lot of things and I might flood the market and I might have to lower my price. So my price may go down based on the demand curve. The demand might not be so great for say 30 units that I sell, so maybe I only make $500, so the price has gone down, etc. So this is quite possible, something that might happen, might flood the market. So in this case, so here we have a revenue function. It's not a linear function anymore. It looks linear up until about here, and then afterwards it's no longer linear. But we can still try to understand the rate of change in the revenue function. We can still try to find, for example, R prime of Q. We can try to estimate, for example, R prime of 20. So the question might be estimate. Okay, R prime of Q is another word for it is marginal revenue. So that's what we're finding here. Our previous usage of the word marginal revenue was to say that if I produce one more unit or sell one more unit, what will be the change in my revenue? In this case, I'm actually thinking about the derivative, the instantaneous rate of change. It's a little bit different, but when you talk about massive quantities of units produced, it's not that much different. So R prime of 20, the thing we want to estimate, is the marginal revenue when the quantity produced is actually equal to 20. So this gives me an estimate on how much more revenue I get when I produce one more unit. Okay, so how should I compute this using the table? So the solution for the estimation problem is to take the average rate of change over first this interval between 10 and 20. So what I'll do is I'll take 400 minus 200, divided by 20 minus 10. That'll give me the average rate of change over the interval 10 to 20. So what is that? That's 200 divided by 10, so that'll be 20. So that kind of makes sense. We already thought of the price as being 20. So that's for this interval, but then I also want to check out the other interval around 20. So next I'm going to work on this interval over 20 to 30. So that's another interval that contains 20. Those are the smallest intervals that contain 20. So now I look at that interval, compute the average rate of change. So that's going to be 500 minus 400. That's the change in R, divided by the change in Q, which is again 30 minus 20, which is 10. In this case, 500 minus 400 is 100, divided by 10 is only going to give me 10. Okay, so those are my two estimates, and to get an even better estimate, I average. So let's average those two estimates. So on the one hand, I have 20, then I have plus, and I have the other estimate is 10, so I add those together and then divide by 2. So that'll be 30 divided by 2, or equal to 15. So that gives me an estimate. So the estimate of R prime of 20, or the marginal revenue when the quantity is 20, is equal to 15. And one can do similar things with the cost function. If you're given a cost function as a table, you would do the same thing, except you would no longer have R, you'd have C. And you'd have the marginal cost. Everything would change from revenue to cost. Marginal cost is the change in the cost if you produce one more unit. It can be also thought of as the instantaneous change in cost. Okay, that summarizes an introduction to marginal cost and marginal revenue.